In this video, we'll be solving a problem that deals with similar polygons. If two angles of one triangle are equal to two angles of another triangle, then the triangles are similar. And two polygons are similar if and only if the measures of the corresponding angles are equal and the lengths of the corresponding sides are proportional. So we'll first state that we have similar triangles, and then we'll use that fact that the triangles are similar to set up a proportion to find any missing sides for our triangles. The problem that we'll be doing is we're asked to find A, B, and H and show work to support your answer. Now you'll notice in this drawing, this is a special situation where I have a right triangle. The big triangle is a right triangle, and from this vertex I drop the altitude to the hypotenuse, which forms two more right triangles, one here on the right and one here on the left. So basically we have three right triangles that are all similar. Now we could separate these two smaller triangles from the big one and look at the proportions that way. An easier method is to use a theorem from geometry. Because we have the altitude dropped to the hypotenuse of a right triangle, the theorem says the altitude is the geometric mean between the segments of the hypotenuse. Now this theorem then only works when we have a right triangle and we have the altitude dropped from the vertex of the right angle to the hypotenuse of the right triangle. And what it says then is that the altitude, which in this case is h, that is the geometric mean. Now, as far as a proportion goes, the means are these two positions right here, the second and the third one that you put in. So h is the geometric mean between the segments of the hypotenuse. And the segments of the hypotenuse are 8, that's this left segment, and 4 is this right segment. So our proportion then that we find from this theorem is 8 is to h as h is to 4. We can do cross products to solve this proportion. We see that h times h is h squared, and then 8 times 4 is 32. So if we square root both sides, we get h is equal to the square root of 32. We can take 32 and do a factor tree. That's 2 times 16. Well, 16 is a perfect square. So this is 2 times 16, which is square root of 2 times square root of 16. And so the square root of 16 we know is 4. So we get h is equal to 4 times the square root of 2. Now we can put that value into our picture, and we have 4 root 2. Now to get our other sides, let's just look at the left side first. We know the leg here is 4 root 2, and we know this leg is 8. So we'll set up a Pythagorean theorem. The square of the two legs is equal to the hypotenuse squared. Eight squared is 64. When you square a term that's 2 factors, I have to square each of those factors. So 4 squared is 16. And then square root of 2 squared is 2. Copy. So I have 64 plus 32 is equal to b squared. If I add these together, I get 96 is equal to b squared. And then square root both sides. So b is equal to the square root of 96. Now let's do factor tree for 96. 96 is 2 times 48. 48 is 2 times 24. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So this pair of 2's and this pair of 2's, I can write this as b is 2 times 2 times, and then what we have left is 6. So that has to stay under the radical. So I have b is equal to 4 root 6. Alright, and then one more. Let's look at this right side. Again, my legs are 4 and 4 root 2. So the square of the legs is equal to the square of the hypotenuse. I should have said this sum of the squares of the legs is equal to the square of the hypotenuse. All right, let's do the math. 4 squared is 16. On this one, we have to square 4, get 16, and multiply it by the square root of 2 squared is 2. Copy this right side. 16 times 2 is 32, so I have 16 plus 32 is a squared. Add these together, I get 48 is a squared. So square root both sides, so a is equal to the square root of 48. I know that 48 is 3 times 16, so I'm just going to break this into square root of 3 times the square root of 16, which simplifies then to 4 root 3.